Hi there, welcome to Math 40. We're going to be continuing our lecture from Lecture Notes Week 8. So this is page 11. I encourage you to have a blank sheet so that you can follow along with what we're going to write on these next few pages. Okay, so before I even begin, I just want to alert you to a typo. On the table here, there is a 4 missing. We're going to be graphing y equals 4 times cosine of 4 over 3x, but there is no 4 there. So please make sure that you replace this with y equals 4 times cosine of 4/3 x. Alright, so for the first time we're going to be taking a look at change in amplitude and change in period together happening at the same time. So as you can see, the table is completely blank. No x values have been given to us. We are tasked with finding what are the important x values that are going to correspond to the highest point of the graph and the lowest point of the graph, as well as the zeros. So we're going to learn how to do that in the next few examples. And in order to get started, I want us to take a first step of finding the period. Now the period, we devised a way to calculate it for every single instance of a sine or cosine function. And that was to take 2 pi and divide it by the number of cycles, which we call b. And b is the coefficient of x always, which is this 4/3. So we have the period is 2 pi over 4/3, which is going to be a 2 pi over 1 times 3 over 4, because we're simply multiplying by the reciprocal of 4/3. Okay, so that's going to give us a 6 pi over 4, which if we divide top and bottom by 2, is going to give us a 3 pi over 2. So we have a period of 3 pi over 2. That's the first step. The next step is to find the step size. And when I say find the step size, I mean find what is the difference between each x value. And if you recall from last week's lecture, in order to find out where the peaks happen or the zeros happen, or the lowest points of the graph happen, they happen at every quarter of the cycle. So what we're going to do is we're going to take the period and divide by 4, because the period defines where one cycle is completed. That means that we're going to take that distance and divide by 4. Okay, so that means taking a 3 pi over 2 divided by 4. Remember, division is multiplication by reciprocal. So we're going to take the 3 pi over 2, multiply by the reciprocal of 4, which is 1/4, and that'll give us a 3 pi over 8. Okay, now to find the x values, that would be our next step. We always start at 0, so x0 is going to be 0. And then the next x values, we simply take the step size and keep adding it to the previous x value. Or sometimes an easier way to think about it is to simply take the 3 pi over 8 and multiply by whatever the subscript of the x value is. So to find x1, we take 1 times 3 pi over 8, which is 3 pi over 8. And that is the same thing as taking 0 and adding the step size. Okay, for the next one, we're going to take 2 times 3 pi over 8, because we're adding 2 of those, right? We're adding 2 of those to 0, or if you want to think about it, is adding 3 pi over 8 to 3 pi over 8, which is just 2 times that amount. And that's going to give us a 6 pi over 8, which when we reduce by 2 top and bottom is going to give us a 3 pi over 4. Right, the next x value will be given by 3 times 3 pi over 8, and that'll be a 9 pi over 8. because this is like a 3 over 1. And finally, x4, that's going to be basically the last quarter, right? This is the first quarter, second quarter, third quarter, last quarter. 4 times 3 pi over 8, that's going to give us a 12 pi over 8, which when you reduce by a 4 will give you a 3 pi over 2. And notice here the last x value is agreeing with the period, and that's usually a good sign. That means that we're on the right track because we are trying to complete one cycle and finding the quarter of the cycle. So these are all the quarters, and the last quarter should agree with one full cycle, which is given by the period. Right, so now that we have these x values, go ahead and transfer them over to the table the way that I have here. Because the next step will be to find the corresponding y values to these x values. So let me just write that down. Step number 4 is to plug the x values into the equation to obtain the corresponding y values. Okay, so for the first one, we're going to have y equals 4 times cosine of 4 over 3 times 0. That is a 4 times cosine of 0. And cosine of 0 is simply 1. So we're going to get a 4 times 1. Okay, so that's just a 4. That means the first point would be a 0, 4. Now, if you take a look at the graph, we're not going to have enough room to plot a 0, 4. So what I'm going to do is I'm going to relabel these tick marks so that they, so that this tick mark instead of being 1 is a 2, and then the 2 would be a 4. Same thing going into the negatives, there'll be -2, and this will be -4. That means that 0, 4 is going to be up here. Okay, next x value, we're going to get 4 times cosine of 4/3 times a 3 pi over 8. The 3's are going to cancel, and it's going to give us 4 times cosine of 4 times pi, that's 4 pi, over 8. So 4 pi over 8. But that's going to reduce down to a pi over 2. Now cosine of pi over 2 is 1, so we end up with a 4 times 1. And that means that we have the point 3 pi over 8, comma, this cosine of pi over 2 is 0. So we're going to get a 4 times a 0, which is simply a 0. Okay. Now, as you can tell, we don't have intervals of pi over 8. That means that we are going to have to try and find where those should be marked. Now, what's going to aid us is a little trick that we've been learning in the past couple weeks, and that is that if we take pi over 2 and divide by half, then we're going to get a pi over 4. And then if we take pi over 4 and divide by half, we're going to get a pi over 8. So these are just intervals, or these now are incrementing in pi over 8. This would be 1 pi over 8. This would be a 2 pi over 8. This next one would be a 3 pi over 8, which I'll write here. Next would be 4 pi over 8, but it reduces down to a pi over 2. That means that this would be a 5 pi over 8, followed by a 6 pi over 8, but 6 pi over 8 will reduce down to a 3 pi over 4. Then we'll have 7 pi over 8, 8 pi over 8, 9 pi over 8, 10 pi over 8, but that reduces down to a 5 pi over 4. 11 pi over 8, and finally 12 pi over 8 that reduces down to a 3 pi over 2. And I say finally because if you notice that is the last x value that we're going to be plotting, so I don't need to go beyond the 3 pi over 2. So we'll stop there, and now we'll go ahead and plot. 3 pi over 8 comma 0 would be here. And that means we can go on to the next x value now. That'll be 4 times cosine of 4 over 3 times 3 pi over 4. The 3's are going to cancel, the 4's are going to cancel, and we're going to have a 4 times cosine of pi. Now cosine of pi is -1, so we're going to have 4 times -1, which is going to give us a -4. So the point that we're looking at is then 3 pi over 4 comma -4. Okay, so 3 pi over 4 is here, -4 is down here. That means that that is our point. Alright, y equals 4 times cosine 4 over 3 times 9 pi over 8. This is going to become a 4 times cosine of, the 4 and the 8 are going to reduce down to a 2, and the 3 and the 9 are going to reduce down to a 3. So we'll end up with a 3 pi over 2. Now cosine of 3 pi over 2, that's 0. So 4 times 0 will be, in the end, 0. That means we have 9 pi over 8, comma 0. Okay, here is 9 pi over 8, and 0 means we stay on the x-axis. Last one is 4 times cosine of 4/3 times a 3 pi over 2. That means that we have a 4 times cosine of 3's cancel, 4 divided by 2 is 2, so we get 2 pi, and cosine of 2 pi is 1. So we get a 4 times 1, and that is 3 pi over 2, comma 4. Okay, so here is 3 pi over 2, comma 4. And so finally the last part would simply be to graph according to these points, to use these points as a guide for the shape of the graph. So for cosine, we know that we start up at the top and then pass through 0 and then curve, go down to the lowest point, which in this case is this -4, then curve and come back up, pass through 0, and continue on to the highest point of the graph. Okay. So that's what the shape roughly looks like. If we look at the characteristics relative to the original equation, the 4 in front of the cosine tells us that the amplitude we should have been expecting was an amplitude of 4, right? And because that coefficient of cosine is positive, we do not expect a reflection about the x-axis. And so that's exactly what we're noticing with the graph. We're starting at 4, which is the way by the way, how cosine starts its graph. It always starts on some positive y value and then continues to go down. And if you check out the amplitude, well, the distance between the highest and lowest point is 8 units, right? So half of that is going to be only 4 units. So our amplitude here is 4, which agrees with what we're seeing for the coefficient of cosine. Now the 4/3 is dictating what the period is going to be. And this is telling us that in 2 pi radians, we're going to see 4/3 of a cycle. So what that means is we're going to see 1 full cycle plus 1/3 more, because 4/3 is the same thing as 1 1/3, right? So that means that in 2 pi radians, we should see 1 full cycle, and if we continue the graph, we're going to see a third of another one. Okay. Which it's a little difficult to draw, but you can see that there is this complete one cycle, and then this chunk between 3 pi over 2 and 2 pi is going to contain what seems to be a third more. Okay. So that is first example that has change in both amplitude and period. Alright, example number 2 is a bit interesting because we see again a change in the amplitude. We still have a coefficient of 4 cosine, so we can be expecting an amplitude of 4 without any reflection. But now if we take a look at the coefficient of x, which determines the period, we see that negative coefficient. So we want to, again, not deal with negative coefficients of x. That's something that we briefly discussed last week. And in order to get rid of that negative, we're going to use the symmetry of cosine. Because cosine is even, that means that this negative can be absorbed, or in other words, we can just ignore it and say that y is equal to 4 times cosine of 2/3 x, because these two are going to be equivalent. The y values are going to be equivalent for every x value. So we can just simply deal with graphing this instead of the negative 2/3. Alright, so if we go through that series of steps that we were looking at for the previous example, the first step is to find the period. And the period is 2 pi divided by b, where b again is the number of cycles, or on the equation, it's going to be the coefficient of x. So we're going to get a 2 pi over 2/3, which is the same thing as a 2 pi over 1 times a 3 over 2, multiplying by the reciprocal. And that means that the period is going to be, well, 2's are going to cancel out, a pi times 3, which is going to give us a 3 pi. Okay, the next step is to find our step size. So the step size, as we saw in the first example, is going to be the period divided by 4. So that is going to be a 3 pi, actually I think it fits here, 3 pi over 4. Okay, next step. Well, next step is to find the x values, starting with x0 being 0. Okay, then x1 we can find by taking the step size and multiplying by 1. So 1 times 3 pi over 4, which is just 3 pi over 4. Then x2 is going to be a 2 times 3 pi over 4, which is going to be a 6 pi over 4. And if we reduce by a 2, top and bottom, we're going to get a 3 pi over 2. Next one is going to be 3 times 3 pi over 4, which is a 9 pi over 4. And last one, 4 times a 3 pi over 4. The 4's are going to cancel, giving us a 3 pi. Okay, so we'll transfer over those values. We'll have 0, 3 pi over 4, 3 pi over 2, 9 pi over 4, and 3 pi. These are all the quarters of the cycle. Notice the cycle is completed in 3 pi radians. So if we divide that by 4, we're getting the quarters of the cycle. And now what we have to do is take those values and plug them into the equation. Now just to make our work go by a little bit faster, I'm going to rely on my calculator to do this, because that way I can just simply go ahead and do second ands and change my x value. First thing that I'm going to do is make sure that I switch to radians, and then we can start plugging in. So the first would be 4 times cosine of negative 2/3, and I'll make sure to include some parentheses in here. So negative 2/3 times 0, which is simply 4. Notice that makes sense because negative 2/3 times 0 is 0, cosine of 0 is 1, 4 times 1 is 4. Okay, next value. Notice I'm doing simply second, enter, so that I can get my previous expression. On your calculator, you can just experiment with where this keyword entry is at, so that it can bring up the previous expression. For some calculators, you can just press the up button, and that'll automatically bring it down for you. Alright, so we're going to be replacing the 0 now with 3 pi over 4, right? Because we want negative 2/3 times 3 pi over 4. So I'll include some parentheses in here, and then have 3 pi over 4. Make sure I'll eliminate that 0, and then I'm going to be missing one closing parenthesis. So that we get 0. Okay, repeat it. But now it's a 3 pi over 2 for the next value. So instead of having 3 pi over 4, we'll have 3 pi over 2. We get negative 4. Okay, then the next one is 9 pi over 4. Okay, so I've got 9 pi over 4. That gives us a 0. And finally, we're just going to have 3 pi. So I'll change this to 3. And we get a 4. And notice these values are not kind of a surprise to us. We chose the x value so that it would give us the highest point, lowest point, and zeros. So the fact that they're coming up nicely this way is a good sign. Alright, so let's see. We're going to need intervals that accommodate for 3 pi over 4, or tick marks that accommodate for 3 pi over 4, 3 pi over 2, and 9 pi over 4. So what I'm going to do is I'm going to take, let's say like 3 pi, draw it somewhere, and divide that interval into 4 equal parts. So this is 1, 2, 3, 4. That'll be my 3 pi. And then half of 3 pi would be 3 pi over 2, so that would be this here. And then half of 3 pi over 2 is going to be 3 pi over 4. And simply what I'm doing there is I'm doing 3 pi over 2 divided by 2, which is 3 pi over 2 times 1/2, which is 3 pi over 4. Okay, that's all the magic that's happening there. Okay, and then if I take a 3 pi over 4, which is the size of this interval, and add it to a 3 pi over 2, I'm going to get a 9 pi over 4. You can verify that on the side again. So if I take a 3 pi over 2 and add a 3 pi over 4, okay, so I'm simply taking the size of this interval and placing it here. So that means taking the 3 pi over 2 and adding this piece, which measures 3 pi over 4. We just want to verify that it really does give us this 9 pi over 4. So this one here, we would need to multiply top and bottom by a 2 in order to have the same denominator. And that would give us a 6 pi over 4 plus a 3 pi over 4. And then adding those two together gives you the 9 pi over 4. And how did I know how to do that? Well, I know that the full cycle happens in 3 pi radians, and when I took that and divided it into 4 equal parts, it gave me 3 pi over 4. So that's essentially the same thing I did, but now on the graph. Take 3 pi and divide it into 4 equal parts, and you'll get these x values. Okay, we're going to be graphing the cycle then. I'll just erase these so they don't get in the way. the highest point is going to be a 4, the lowest point is going to be a -4. So when we draw our tick marks, we want to make sure that we can fit in those values. That means that I'll make this the 2 and this a 4. So at 0 we get a 4, at 3 pi over 4 we get 0, at 3 pi over 2 we get -4, at 9 pi over 4 we get 0, and at 3 pi we get 4. That means that we complete one cycle in this manner. Alright. Now this is supposed to extend all the way down to 15 pi over 4 in the positive direction and to -15 pi over 4 in the negative direction. So we have to figure out where those are. Let's see if we can, kind of figure it out. Well, we said the size of in between the interval is 3 pi over 4. So if I add a 3 pi over 4 here, okay, so if I do this, this is essentially going to become a 12 pi over 4 plus a 3 pi over 4, right? Just rewriting it so I have the same denominator. And that's going to give me a 15 pi over 4. Okay, so that means we only have to extend it to one more tick mark to the right. So that means that we would have, if you punch it into the calculator, there are two things. The first one is we can have an educated guess as to what's going to happen at 15 pi over 4. And well, since these two are equally spaced apart, we can guesstimate that this is going to be, it's going to go down to 0. But we can always verify it by punching it into the calculator. So instead of having this 9 pi over 4, I'm going to replace that with a 15 pi over 4. Okay, now this is giving me a funky answer. This is saying -8 times 10 to the -13. That's because with calculators, they always represent numbers to a nearest decimal place. So this is actually a very, very, very small number, very close to 0. When I say very small number, I mean very close to 0. So it's probably best that we just kind of verify by hand because the calculator is not being too helpful at this point. But if we plug that into this equation, we're going to get y equals 4 times cosine of -2/3 times 15 pi over 4. And that's going to be a 4 times cosine of the 2 and the 4 are going to simplify to a 2. The 3 and the 5 are going to simplify to a 5. So we get -5 pi over 2. And if we look at what is cosine of -5 pi over 2, that's going to be 0. So we're going to get a 4 times a 0, which is simply 0. Okay, so that confirms our suspicions that a 15 pi over 4, we're going to go down to 0. Okay, what do we do beyond that? Because we still need to extend to -15 pi over 4. Well, first things first, let's just go ahead and label the tick marks. Okay, so 1, 2, 3, and 4. This is going to be -3 pi. This is going to be -3 pi over 2. This will be -3 pi over 4. And this will be -9 pi over 4. And I'm quickly getting these values simply by reflecting them over, right? If 3 pi over 4 is -3 pi over 4 is a reflection of 3 pi over 4. Then 3 pi over 2 and -3 pi over 2, well, those have the same distance for 0. Same is true about these last tick marks. All the way down to -15 pi over 4. Okay, then what? Well, then we remember the symmetry of cosine. Cosine, we said, is an even function, and any even function reflects about the y-axis, meaning there are mirror images, the left-hand side and the right-hand side. So if we use this as a mirror, that means that the 3 pi over 4 comma 0 is going to reflect to negative 3 pi over 4 comma 0. The 3 pi over 2 comma negative 4 is going to reflect over to negative 3 pi over 2 comma negative 4. Oh, and I think I probably mislabeled this point. This one should have been here. And there. Okay, that's better. Alright, then 9 pi over 4. At 9 pi over 4 we have 0. That means at negative 9 pi over 4 we'll have 0. And then at 3 pi we have 4. That means at negative 3 pi we're going to have 4. And negative 15 pi over 4 will be a reflection of 15 pi over 4. So it'll also have a y value of 0. So we're going to see the graph oscillate in the same manner that it did for the positive x values. Yeah, so that's what we get. Let's check the attributes now. Does it have an amplitude of 4? Well, highest value is 4, lowest value is negative 4. The distance between these is 8. Half of that is 4. So, yep, it still has that amplitude of 4 with no reflection about the x-axis, right? It started on the positive y-axis, not on the negative. So that looks good. And then the period, we found it to be 3 pi. So period is 3 pi. Does that agree with what we saw here for B? Well, for B, it says, well, you're only going to be completing, if we're looking at the positive version of it, you're only going to be completing 2/3 of the cycle in 2 pi radians. So what that means is that you're going to have to take a little bit longer, you're going to have to take more than 2 pi radians in order to see the full cycle, meaning the period has to extend. And that's exactly what's happening here. We see the period extend beyond 2 pi into 3 pi. Okay, so all is in agreement. For one last example, example 3, we have to graph y equals 2 times sine of negative pi x for x being between negative 3 and 3. So again, we have that negative coefficient for x. We're going to use the symmetry of sine. Now, if you recall, sine is an odd function. And unlike in an even function, we simply can't ignore the negative, or we can't absorb the negative away. For an odd function, what that means is if you have an f of negative x, you bring out the negative in front of the function. So it's negative f of x. Okay, so applying that to what we have here, that means that we're going to end up with y is equal to a negative 2 times sine of pi x. So I'm bringing out the negative to the front, but there is that 2, so I need to make sure that I bring it all the way outside. So think of it kind of like a negative times a positive 2 gives us a negative 2. And now this is the function for which we're going to be finding the period. Okay, so here's step 1. The period is 2 pi over b, where b again is the number of cycles, or the coefficient in front of x. So we have a 2 pi over pi. That means that the pi's cancel and we get a 2. The next step is to find the step size. And the step size is going to be the period over 4. That means that we have a 2 over 4 for a final step size of 1/2. Alright, so now we need to find the x values, starting with x0 being 0. Okay, the next x value will be given by 1 times the step size, so 1 times 1/2, which is just 1/2. Next x value will be 2 times 1/2, which is simply 1. Next x value will be 3 times 1/2, or 3/2. Last x value will be 4 times 1/2, which is going to give us a 2. Okay, so we're finding all of the quarters of the period. If the period is 2 and you divide it by 4, you're going to get each quarter happening at multiples of 1/2. Okay. Alright, so now we're going to transfer those over. We're going to have 0, 1/2, 1, 3/2, and 2. And we're going to plug those into our equation to see what corresponding y values we get. Okay, so the first one is 2 times sine of negative pi times 0. So we get 0. Okay, then we have negative pi times 1/2. I'll go ahead and introduce the parentheses here, in which case we no longer need this times. I mean, we can leave it there, it doesn't hurt. Okay, and we're going to get negative 2. Alright, next one is 1. So I'm just going to delete the 1/2 and get 0. Next one is 3/2. We get 2. Next one is 2. We get 0. Okay, so let's plot these on our graph now. We need to make sure that we have all the way up to 3. So let's see, and that we can draw all of the half intervals. So if we make this, let's see, 1, this would be 2, and then we would have 3 here at the end. Then this would be 1/2, 3/2, and 5/2. And same thing going in the negative direction. We'll have -1, -2, -3. This will be -1/2, -3/2, -5/2. And let's see, lowest point is -2, highest point is 2, so we can make this 1, 2, and then -1, -2. And now we have all the tick marks that are needed. Let's plot the points. We got 0, 0, 1/2, comma, -2, so that's down here. 1, comma, 0, 3/2, comma, 2. 2, comma, 0, and if we continue the pattern here, well, let's see, at the next quarter, this is already completed one cycle, so we're going to start repeating. We're going to go down to -2 and then back up to 0 to get this shape of the graph on the positive x-axis. Okay, now we continue into the negative x-axis, into the negative x values. If it already completed a cycle between 0 and 2, that means that going into the negatives, we're going to start repeating some values. So this is going to go up to a +2, then down to 0 at -1, down all the way down, down all the way to -2 at -3/2, up to 0 at -2, up to 2 at -5/2, and down to 0 at -3. And here I'm just simply using the pattern of the graph. I know that it's oscillating back and forth between 2 and -2, but you could always verify what the y values truly are by taking the x value and plugging it into the equation. Like for instance, let's say that I wanted to verify that at -1/2 we go up to 2. Well, then we can simply plug it in. Okay, I'm going to replace that 3/2 with a -1/2. And we see that we go up to 2. Okay, so that verifies that. Let's say that I want to verify the -1 now. Well, what I could do is simply delete the divided by 1/2. we get the 0. Okay, so all those y values you can verify by plugging them into your equation. Once you are satisfied with that and convinced, you can start drawing the shape of the graph. Okay, so again, let's take a look at what we were expecting simply by looking at the coefficients of the equation versus what we have on the graph. So once we took into consideration the symmetry of the function and we said, okay, this equation is equivalent to this one here, we now have a coefficient of -2 for sine. So that means two things, right? Last week we learned the negative causes the graph to reflect about the x-axis. So sine normally begins going up and then coming down. This one begins going down and then going up, which is a sign of reflection, which means that it is consistent with that negative being there. The other change we saw from the original sine graph is that we have an amplitude of 2. And well, again, if you look at the difference between the highest point, which is 2, and the lowest point, which is -2, that's a distance of 4. Take half of that and you get 2. So the amplitude is consistent with what we see in the coefficient. All right, what about the period? Well, the period was 2 pi, would originally be 2 pi, but because of the pi, we divided 2 pi by 2 to get a period of 2, and well, that's what we're seeing on the graph as well. And one cycle of sine gets fully completed between 0 and 2, and then if you want to continue the graph, you'll see a repetition of it after the 2, or if you decide to go into the negatives, you'll see a repetition of this portion of the graph happening between 0 and -1/2. Okay, so in any case, we see that the period will indeed be consistent with 2.
Okay, so back to Desmos. Desmos is an online graphing calculator. It's very easy to use. It looks like what you guys are seeing now on the screen. And I'm just going to plot, or rather I'm going to graph y is equal to x squared, which is a parabola with a vertex at 0, 0. You can also plot and label points. So like in this case, I'm going to plot the origin. And we're trying to consider vertical translations, which means moving the graph up and down, and how do we accomplish that? So if I add a constant 3 to the original y is equal to x squared, notice that the origin, the vertex at the origin has now shifted up to 0, 3. And really any other point that was on the original graph, so like 1, 1 was in the original y is equal to x squared, is going to be shifting up by 3 units. So 1, 1 is going to shift up to 1, 4, right? So this point, this black point is now up here, the red point 1, 4. And the same is going to be true about, for instance, if we consider maybe like 2, 4 on the original graph. So this blue point here is now going to shift up to 2, 7, which has been color-coded green. So adding that constant of 3 will cause all of the original y coordinates of the points to be increased by 3. And this is going to be true, or something similar is going to happen if we have minus instead of plus. So if I, let's say now create a new graph that is y is equal to x squared, we'll say minus of 5, and I'll zoom out so we can see the rest of the graph. We see that the vertex is no longer at 0, 0, it's at 0, -5. That's because, again, the y coordinate has shifted down to 0, -5. So adding the constant to the original graph whether it's a -5 or a +3, is going to be moving the graph up and down. It'll be up if it's positive or down if it's negative. And the same thing is going to happen when we consider the trigonometric functions. Okay, so we're going to now look at the example on page 1. Let me come back to DocCam. Here we have the graph y equals a -3 plus 2 times sine of negative pi x over the interval -3 to +3. Now I want to go back to lecture notes week 8 because we graphed something very similar. We actually graphed y equals 2 sine of negative pi x. So I want us to compare the graph that we're going to get for this example versus the graph that we got last week. Sorry, not last week, on Monday. So here it is. This is the graph. It's on page 13 of lecture notes week 8. So for the important x values that we got, it was 0, 1/2, 1, 3/2, and 2. So I'm just going to transfer over those points. And write a note here, see page 13 on lecture notes week 8. I'm also going to transfer over the y values, but not write them directly into the table quite yet. I'm going to have another row here. This is kind of like my reference row. It's 2 times sine of negative pi x that we found y values for. And when x was 0, the y value was 0. When x was 1/2, we got -2. When x was 1, we got 0. When x was 3/2, we got a 2. And when x was 2, we got a 0. Okay. Now, from what we saw with the parabola, we said whenever we add a negative constant, it shifts everything down. It shifts all of the y values down by whatever that constant was. So in this case, if 2 sine of negative pi x is 0 when x is 0, that means that this equation is going to be a -3 plus 0, where I'm actually just transferring this value here. That is the value of this equation. Nice if I take, if I consider x is equal to 1/2, we got a y value of -2. So now we're just going to add the constant of -3. So we get -3 plus a -2, and that's a -5. Oh, I'm sorry, I forgot to write it as equal to -3 on the previous one. Again, we're simply taking the -2 and adding the constant of -3. And we just we keep repeating that process. So this one's going to be -3 plus 0. So it's going to give us a -3, followed by a -3 plus 2, because this y value without the shift was a 2. So we'll get a -1. And then a -3 plus 0, which is going to be -3, because this, well, we're just transferring over the 0. So the final points that we're going to be graphing is a 0, -3, okay, from here. In fact, I kind of want to highlight this because I know at this point we have several values, but it's going to be the 0 with the -3, 1/2, -5, 1, -3, 3/2, -1, and 2, -3. Okay, those are the points we're going to be graphing. Okay, so let's attempt that on the graph above. I'm going to first plot my tick marks, or draw my tick marks. This is I'll say this is a 1/2, 1, 3/2, 2, 5/2, and 3. And going in the negative direction, we're going to have negative 1/2, negative 1, negative 3/2, negative 2, negative 5/2, and negative 3. Okay. Now at 0, we go down to negative 3, and actually I didn't label those, so let me label those real quick. Okay, actually I'm going to have to change those tick marks because we have to go all the way down to negative 5, so we'll do, this will be negative 1, then this will be negative 2, negative 4, and negative 6. Okay, so now 0, negative 3 would be this point. 1/2, negative 5 would be this point. 1, negative 3 would be here. 3/2, negative 1 would be here. And 2, negative 3 would be that point there. So we get a curve that looks like the following. Okay, now they do want us to graph this. They want us to extend it beyond 2 all the way down to 3. So what we can do is we can find out what's going to happen at 5/2 simply by plugging it into the equation or by following the pattern of the sine graph. This is acting as the new axis of oscillation. And what that means is that the graph keeps oscillating back and forth with this line as the center of it all. So after it reaches that kind of like neutral point, it's going to go down to a negative 5 again and back up to the negative 3. And so we're going to see this behavior happening. But of course, we can always use our calculator to help us verify what happens at 5/2. So the full equation is negative 3, or the full expression for y is negative 3 plus 2 times sine of negative pi times, in this case we have 5/2, so 5/2, and that would be it. So we do get the negative 5, which is what we've plotted at this point. And then to verify that at 3, we come back up to negative 3. We can, again, punch it into the calculator. So now instead of having 5/2, we're going to have a 3. And we get that negative 3 that we plotted. Okay. Now going in the negative direction, because we are supposed to extend out to negative 3, we can see that the pattern continues so that this goes up to a negative 1. So we should see a point here at negative 1/2, negative 1. Then at 1, it should go back down to a negative 3. At negative 3/2, it should go back down to a negative 5. Then a negative 3 again, negative 1, negative 3 again. So that the rest of the graph curves in that manner. Now just to verify, let's check some of these x values, starting with maybe negative 1/2. So if I type negative 1/2, here we get a negative 1, which is this point. If I check negative 1, we're going to get negative 3, which is this point, and so on and so forth. You can just continue to plug them in, and you'll get those points. All right, now for comparison. Well, okay, actually before we compare, let's talk about some of the characteristics of this graph. What is going to be the amplitude? Well, the amplitude is going to be the difference, or half the difference, between the highest point and the lowest point. The highest point on the graph is negative 1. right? So it's going to be -1. The lowest point is a -5, so minus a -5. And so we get, actually let me bring this over, we get a 1/2 of -1 plus 5, so that is a 1/2 of 4, which is 2. And that means that we have an amplitude of 2. And that makes sense because if we use kind of this line at y is equal to -3 as the horizontal line about which the graph is oscillating, then we see a distance between that line and the highest point. We see a distance of 2. And that's not the only reason why that makes sense, but also if you take a look at the original equation, we have y is equal to -3 plus 2 times sine of -πx. So this number is the coefficient of sine, which also determines what the amplitude is going to be. So we see that amplitude of 2. What are some other characteristics? Well, if we look at how long it takes the graph to complete one full cycle, just considering like here at 0, if we start considering from 0 on to the right, it's going to go down and then up and then back down. So this part of the graph is already repeating what happened between x is equal to 0 and x is equal to 1/2. So that means that from 0 to 2, we complete one cycle. And that means that the period is going to be 2. Okay, again, that doesn't surprise us too much because if we were to calculate the period by using the 2 pi over b formula, b in this case is the pi, and remember, here when we have a negative pi inside, or a negative whatever constant it may be, as long as we have a negative coefficient inside of sine, we always bring it out because sine is an odd function. So this is actually equivalent to -3 minus 2 times sine of pi x. Okay, I'll just write these are equivalent because sine is odd. And so we bring the negative outside. And so what we see then is that b is actually this pi. So when we calculate what the period is going to be, we're going to have a 2 pi over pi, which is going to cancel and give us a 2. Okay, so the period is 2, the same as what we're observing on the graph. Okay, and then finally the characteristic that we're actually considering right now specifically is that translation downward, or that shift downward. If we compare against the original, or not the original, but the example on page 13, that was 2 sine of -πx, so it just didn't have this -3. And the graph would pass through the origin and then go down to -2 being the lowest point. So this point that was at the origin has actually shifted down to 0, -3, right? The graph originally looked something like, and I'll do this, I'll draw lightly what it looks like without the shift. Without the shift, it looks something like this. So all of the points on the original graph, including this point 0, 0, is shifting down to now the point 0, -3. And that has directly to do with the -3 constant that is being added to sine, the sine term. And so this is a shift down. Okay. So any questions about the graph? And okay. Now this example, we didn't have to plot, or we didn't have to go through all of the steps from scratch because we basically borrowed most of the work from page 13 on lecture notes week 8. But in this next problem, problem 2, we're going to be going through all of the steps from the very beginning. Okay, so problem number 2 is asking us to complete one cycle of the equation h is equal to 139 minus 15 cosine pi over 10 t. And they mentioned that this equation is used to describe the height of a Ferris wheel rider at any given time t. So the first thing that, and again, these are always guidelines. If you have already taken a trigonometry course in the past and have a different approach for graphing these that works for you, by all means, you can use your own approach. But these are guidelines that I like to provide because I feel that it organizes everything nicely. So the very first step that you want to take, which I'm going to call step 0, is to only consider the equation that doesn't have the constant term in it. So here the constant term is 139. I'm going to ignore it for now and pretend that I only have the negative 15 cosine of pi over 10t. All right, and so we then focus on the important x values that are associated to that graph. And in order to find those, we need to first know what the period is. So step 1, or what I'm labeling as step 1 here, is the same step 1 that we've been taking to in order to graph the other trigonometric functions that we've seen this far. So b in this case is pi over 10. That means that the period will be a 2 pi over pi over 10. And when we divide by a fraction, it means multiply by the reciprocal. So that means a 2 pi over 1 times a 10 over pi. The pi's are going to cancel, and then 2 times 10 will be a 20 over 1. So we get that the period is 20. Next step, again, this is the same as what we've been doing for the other graphs, is to find the step size. And the step size is always the period over 4, because all the important parts of the graph, like the peaks, the zeros, and the lowest points on the graph, happen at a quarter of the cycle. So if the cycle gets completed in 20, whatever this may be, 20 radians or 20 minutes if this is time, then a quarter of that would be 20 over 4, which is 5. So at 5 minutes, we're going to see either a peak or a 0, depending on which trig function we're considering. In this case, we're considering cosine, so that means that we're going to be seeing a 0. But let's see more explicitly in step 3. Step 3, we look at the important x values. Here we're using variable t instead of variable x. So I'll use variable t. We always start at 0. So t0 is 0. And then the next one is going to be 1 times the step size. So 1 times 5, which is just 5. Then 2 times 5, which is 10. Then 3 times 5, which is 15. And finally, the fourth quarter, 4 times 5 is 20. And if we've done it correctly, this last x value or t value has to agree with the period. Because again, we're just taking the time that takes for the whole cycle to complete and dividing it into 4 equal parts. And this, yeah, thank you. So this is step size. Okay, so now that we have those t values, we're going to transfer them over onto the table of points. And there is a typo here. We can just change this. Instead of x, we're now dealing with the variable t. The first t value is 0, then 5, 10, 15, 20. And from there, what we can do is we can directly plug it into the h function. What I like to do though is I like to plug it back into the y that we defined, the one that doesn't have the constant, meaning the one that is only negative 15 cosine of pi over 10t, because I'd like to make sure that the graph is oscillating correctly with these t values that we found. And then once I'm convinced that, hey, yeah, it looks like the t values that we picked correspond to peaks, zeros, and lowest points, then I go in and I attach the constant. Okay, so let's see, if we plug in a 0, this one we don't need a calculator for, we could do a pi over 10 times 0, that's 0, and then cosine of 0 is 1, and then negative 15 times 1 is simply negative 15. The next one we could also do, but if you want to use your calculator to verify, you can, but if you replace the t with the 5, we get pi over 10 times 5, so that's a 5 pi over 10. Then 5 pi over 10 is pi over 2. Cosine of pi over 2 is 0, and negative 15 times 0 is 0. And then if we plug in the 10, 10 times pi over 10, we'll cancel out the 10 so that we just have pi. Cosine of pi is negative 1. Negative 15 times negative 1 will give us a positive 15. And then this for 15, 15 pi over 10 is going to reduce to a 3 pi over 2. Cosine of 3 pi over 2 is 0, and negative 15 times 0 is 0. And last one, replace it with 20. 20 pi over 10 is going to be 2 pi. Cosine of 2 pi is 1. Negative 15 times 1 is just negative 15. All right. So we have the y values. We have the values without the constant term of 139. Now let's plug it in, or now let's actually account for the 139. So the h value is going to be 139 plus the negative 15, because these two are the same. So I'm going to plug in what we got for that value. And then a 139 plus a negative 15 is going to give us a 124. Okay, then for the next value, we're going to take 139, the constant, and add to it what we got for negative 15 cosine t at that point, which is 0. So we get 139. Then for the next one, we're going to take the constant, 139, and add to it what we got for negative 15, which is 15. For negative 15 cosine of pi over 10t, which was 15. And that means that we get a 154. Here, next one will be 139 plus 0, so that'll be just 139. And then 139 plus negative 15 again, because this is negative 15, so we'll get a 124. Again, let me just reiterate. The only reason why I performed this step was because I wanted to be convinced that these t values, we chose them so that this graph is oscillating correctly, meaning so that we reach zeros and peaks and lowest points. Okay, I could have completely skipped over this step and simply plugged it into the H equation. Okay. And if you prefer to do that, you can just use your calculator, or you can also do it by hand. We could do 139 minus 15 times cosine of 0 times pi over 10. And we get 1.4, which is this first value. If you plug in the 5 for t, okay, then replace this 0 with 5, and we get 139, which is this value. If you want to plug in 10, and we get the 154. Okay. So this row down here is unnecessary, but I just kind of do it as extra verification. Okay, so questions up to this point? So now we're going to take these t and h values and plug them in, or plot them on the graph. The first one is 0, 124, which clearly is a very large number, and I won't be able to fit it with the tick marks that are given here. So we're going to be drawing this symbol that kind of looks a little bit like a thunderbolt, but this is describing a break in the continuation of the y-axis. And so I'm saying I'm going to jump from 0 to maybe like 120 for this tick mark. And then I'll continue in increments of 5. So this will be 125, 130, 135, 140, 145, 150, and 155. Okay, and so we said the first point is 0, 124. Oh, and let me actually label the t values as well. Can change this from x to t. We'll make this 5, 10, 15, and 20. Okay. So 0, 124, that's going to be approximately here. Then 5, 139, that's approximately there. 10, 154 is approximately here. 15, 139 is approximately here. And 20, 124 approximately here. So because we know that cosine is curvy, we'll draw a curve. This then looks more or less like that. So we are stopping at 20, but if that were to continue, we would see it oscillate and go back to this, oscillate about this horizontal line, which is now at y equals 139. So it's no longer oscillating down here about the x-axis. It's shifted up to y equals 139. Okay. So any questions there? I do want to talk a little bit about the application that this graph is supposed to have. They say that this is describing the height of a Ferris wheel rider at any given time t. And so if we think about a Ferris wheel, you board it at the bottom, right? You board it down here at the bottom. And so they're saying that at time 0, when you board it down here, you're at a height at 124. I'm gonna guess this is probably inches. Okay, 124 inches. So maybe you're about 10 feet off the ground when you board. Okay. And then at a quarter of the way, which happens, a quarter of the way is 5 minutes. And a quarter of the way on the circle would be there. Okay. That is when you reach a height of 139, right? Here's a quarter at 5 minutes. And if we look at the height, that is at 139. Okay, so there's 139 inches here. Okay. Then at 3/4 of the way, at 2/4 of the way, which is halfway through the ride, you're at the top of the Ferris wheel. And at the top of the Ferris wheel, there's a maximum height of 154, right? So that happens at 10 minutes. So at 10 minutes, we're at height 154, which is up here. Then once you've reached the largest possible height, you're gonna come back down at 3/4 of the way through the ride, which happens at 15 minutes, and you're back at this height of 139, and we can see it here on the graph at minute 15. We're at height 139, and then once you've made it all the way back down to where you first boarded, we're again at a height of 124 inches. Okay. So any questions? It's a very, I don't know if that's realistic for 154 inches, because that's a difference of what? Maybe like 3 feet? I don't know if that's possible. So maybe this is in feet. I don't know. They don't give us the unit of measurement, but in any case, that's the behavior. That's what what the graph is describing. Okay. Any questions? Any questions here? All right, so let's summarize what we've found so far. If we add a constant, which we're just calling in general k, to the term with sine or cosine, and that constant is positive, what does it do to the original graph? What did we see happen, like in this example? This 139 does what to the graph?
It shifts the graph up, right?
Yeah, exactly. Very good. Yep. So it's going to shift the graph up. By k units, whatever that k number is. And then if that number is negative, kind of like what we saw on page 1 with this -3, we actually see a shift down, which is determined again by that k. Okay, so this shifts down. And that's by k units. So just as extra practice, we're not going to graph it completely or at all, actually. We're just kind of going to identify the important information. Sorry, not extra credit, extra practice. So as extra practice, let's consider, for example, y equals, we'll say like 10 minus a 5 times sine of negative pi x. And we're going to look at what is the period, what is the amplitude, is there a reflection about the x-axis? And then finally, what is the vertical shift? So let's start with period. The period is going to be 2 pi over b. What is b in this case? What is b? Good, it's pi. Very nice. Yep, it's pi. And we say it's the coefficient in front of the x, but currently as we have it, there is a negative. And what we have to be careful is that this number b can never be negative. So we always want to use the symmetry to help us get rid of the negative in the argument. In this case, it's going to be equivalent to a 10 plus 5 times sine of pi x, because what we did is we brought that negative outside since sine is odd. Yeah. So let me just write that here. So that means that b is this positive pi. Okay, so the period will be a 2 pi over pi. Now 2 pi divided by pi is just going to be 2. Okay, so that means that we have period of 2. What is the amplitude?
5.
Good, yep, it's 5. It's this number that is in front of the sign, so the amplitude will be 5. Very nice. Is there a reflection about the x-axis? No, good. There's not a reflection about the x-axis, and why not? What is determining whether or not we have a reflection about x-axis? Good, so in the amplitude, we use this coefficient of sine, right? And this is not negative. If this were negative, then we would have a reflection about the x-axis. But because that constant is positive, the reflection is a no. Good. All right, what about the vertical shift?
Yes.
Yes, good. So it does have a vertical shift. In which direction?
Up.
Up. Very good. And it's this 10 that's helping determine that vertical shift. So it's an upward shift. So it's going to be a shift up by 10 units. All right. Good. So any questions here?
Professor, this just reminded me, I took the latest quiz reflection,
Mm-hmm.
and the reflection about the x-axis, that portion was not, I wasn't able to submit an answer.
Oh, okay. Is it just like not allowing you to enter?
Yeah,
Okay.
I think there are 2 questions, and that's the only part that won't, just the reflection part won't let me.
Okay. All right. So let me look into it. This is for number 14, right? For Mondays.
Yes.
Let me look into it and I'll get that issue fixed. Well, thank you for letting me know. Okay. So the next thing that we're going to talk about is horizontal translations, which means shifting left to right. So again, I want to go back to Desmos. Let me share Chrome. Okay, and now I'm going to get rid of all of these other graphs. I'm just going to keep the original parabola y is equal to x squared. So notice what happens if instead of subtracting a constant away from the whole x squared term, if we take it away only from x. So for instance, let's say that I do x minus 3 and then square the result. So I still have a parabola, but now that parabola seems to have shifted to the right. In fact, if we take a look at the vertex for it, it's shifted to 3 comma 0. Right. So this vertex is moving, and same for all the other points. So 1 comma 1, which is on the original parabola, is shifted over to 4 comma 1. And if we take a look at maybe one more point, we'll do like say a 2 comma 4 has shifted over to a 5 comma 4. So all of the points are moved to the right if we subtract the 3. What happens if we add a number instead? So for instance, what happens if we do like x plus 5 squared? Well, then we see a shift, but it's no longer to the right, it's actually to the left. And the vertex is at 0 comma negative 5, which shows us that it's actually a complete 5 units. Oh, and I keep writing the wrong order. Negative 5 comma 0, which shows us that the vertex is shifting over to the left by 5 units, as well as all the other points. Again, this is not going to be unique behavior to just parabolas. This is true in general about any graph. If you take the argument and you add some type of constant or you subtract a constant, it's going to shift the graph left or right relative to not subtracting any constant from the argument. Okay, so let's take a look at page 4 for an example with cosine. And so again, I'm going to go through and give you some guidelines. For step 0, I'm going to let theta represent x minus pi over 3. So what I like to do is I always substitute x minus the constant or x plus the constant with simply just theta, so that it's easier for us to identify what the period is and what the amplitude is, and then from there we consider what are the x values, the important x values of the graph. Okay, so once we've done that, and actually let me write one more thing. Once we've let theta be x minus pi over 3, then the equation that we're looking at is cosine of theta, because we've made that substitution. So it looks a lot simpler. And if we try to look for the period is going to be 2 pi over b. B in this case is simply a 1, right? There is no coefficient other than a 1 that is invisible there. So we have a 2 pi over 1, which gives us a 2 pi. For the next step, we look at the step size. And the step size is still the period over 4. So that's going to be 2 pi over 4, which is a pi over 2. And then for step 3, we look at the what would the important theta values be if we were actually graphing y equals cosine theta? Well, the first one would always be 0. Is the theta 0 would be 0. Then we would have theta 1 is 1 times the step size of pi over 2. So we would get a pi over 2. Then 2 times the step size. So that's a 2 times a pi over 2, which is pi. Then a 3 times pi over 2, which is 3 pi over 2. A 4 times a pi over 2, which is a 2 pi. And that would be it. And we made it back to the period of 2 pi. Okay. But we're not graphing y versus theta. We're graphing y versus x. So we need to find a way to relate these theta values back to the original variable of x. We do have a way to do that because we define theta equals x minus pi over 3. So from this expression up here, we can solve for x by simply adding pi over 3 to both sides of the equation. If we do that, we're going to get that x is equal to theta plus pi over 3. Again, what I did was simply add pi over 3 to both sides. These are going to cancel, leaving us with x equals theta plus pi over 3. So now with this general formula, we can find the important x values. We can write x0 is going to be theta 0 plus pi over 3, and theta 0 is 0. So we get 0 plus pi over 3, which is pi over 3. And that'll be the first important x value. Then the next one, x1, will be theta 1 plus pi over 3. Again, this is just the formula. Okay. Theta 1 we found to be pi over 2. So we're going to have a pi over 2 plus pi over 3. Now to add those together, we need to have the same denominator. So I'm going to do some side work. Pi over 2 plus pi over 3. Multiply the first fraction by a 3 over 3. Multiply the second fraction by a 2 over 2. And we get a 3 pi over 6 plus a 2 pi over 6, which is a 5 pi over 6. So this becomes a 5 pi over 6. Okay, next one, x2 will be theta 2 plus pi over 3. This comes from the original equation. And now we plug in what is theta 2. Theta 2 is pi. So we get pi plus pi over 3. A little bit of side work, just multiplying this top and bottom by 3. Will give you a 3 pi over 3 plus pi over 3. That's 4 pi over 3. So far, so good. Do you guys have any questions? We still have 2 more x values to go, but please stop me if you do have any questions. And then x3 will be theta 3 plus pi over 3 from the formula. Then we replace theta 3 with with its value, which is a 3 pi over 2 plus pi over 3. If we do some side work, we're going to get 3 pi over 2 plus pi over 3. That means multiply the first fraction by 3 over 3, multiply the second by 2 over 2. We're going to have a 9 pi over 6 plus 2 pi over 6, which is an 11 pi over 6. So this is 11 pi over 6. And last one, x4, will be theta 4 plus pi over 3, which is a 2 pi plus pi over 3. And multiply top and bottom by 3 here, and we'll have a 6 pi over 3 plus pi over 3. That is a 7 pi over 3. So now we have the important x values, which I'm going to transfer over to the table of points. Okay, so the first one is pi over 3, followed by 5 pi over 6, 4 pi over 3, 11 pi over 6, and 7 pi over 3. And we can plug them into the calculator or into our equation using our calculator. Let me just go ahead and get the lighting here a little bit brighter. Okay, so we'll have cosine of pi over 3. Oh, actually, let's do that. Pi over 3 minus pi over 3. That's a 0, right? Cosine of 0 is 1. So the first y value that we get is a 1. Next, we're going to have cosine of 5 pi over 6 minus pi over 3. And we get 0. And then we're going to have a cosine of 4 pi over 3 minus a pi over 3. That's -1. And then we have 11 pi over 6. That gives us a 0. And last one, 7 pi over 3. And that gives us a 1. We have all of the y values that we need, along with the x values. On the x-axis, we need to make sure that we have 5 pi over 6 and 11 pi over 6. So let's go up in intervals of pi over 6. This first one is pi over 6. Then this would be 2 pi over 6, but it reduces down to a pi over 3. This would be a 3 pi over 6, but it reduces down to a pi over 2. This would be a 4 pi over 6, but it becomes a 2 pi over 3. And I think maybe it's easier if I do it with pi over 6, because I know that last time I had some questions regarding how I was drawing the tick marks. So let me just draw the tick marks with simply pi over 6. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. It'll just continue 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, 13 pi over 6, and 14 pi over 6. Now, out of all of these, most of these are going to reduce. So 5 pi over 6 doesn't reduce, but then 6 pi over 6 becomes pi, 7 pi over 6 can stay. 8 pi over 6 becomes 4 pi over 3. 9 pi over 6 is 3 pi over 2. This is 5 pi over 3. 11 pi over 6 remains the same. This becomes a 2 pi. This remains the same. And this becomes a 7 pi over 6. Sorry, a 7 pi over 3. So questions about the tick marks. The tick marks are okay? All right, and then I'm going to label my y. So that'll be 1, and this will be -1. Then at pi over 3, which is here, we have a y value of 1. At 5 pi over 6, which is here, we have a y value of 0. At 4 pi over 3, we have a y value of -1. So that'll be down here. At 11 pi over 6, we'll have a y value of 0. So that's here. And then at 7 pi over 3, we'll have a y value of 1, which is here. So the graph is going to curve, oops, more or less like this. Yeah, so notice what's happened to the graph. It still has an amplitude of 1, right? The highest point is 1, the lowest point is -1. The distance between the highest and lowest is a distance of 2, so half of that is 1. The amplitude hasn't changed. Period is, well, one cycle gets completed between pi over 3 and 7 pi over 3. So if we take the difference between those 2 points, 7 pi over 3 minus pi over 3, that gives us a 6 pi over 3, which is still a 2 pi. Okay, so we see it complete in 2 pi radians. So that hasn't changed. That remains the same. But what has changed is that the graph for cosine normally begins at 0, 1 and then decreases and increases. Here it began at pi over 3, 1, which means that there is this shift that's happening to the right. And it's for pi over 3 units.